Hey crew, back for the next step in the CNC string art. So at this stage you should have your material or your block of wood that we're simulating and some sort of pattern that's on that. In this case I'm doing the state of Wisconsin, but I've also shown you a few other pattern options that I was doing for practice in the last video. So if you're at this stage, you have all the holes you think you need to make your string art project. The next thing to do then is to start working with a machine, so to speak, on here and virtually simulate the machine doing the work for you. And we do that with the Cam tab up top. So we're going to move to the Cam tab. So go ahead and click on that. When you click on that tab, it might just take a second to load, or it does switch right away. I was expecting a tab to show up right here on the browser, but I guess that happens right when you click Setup. There we go. So after you click Cam, we click the Setup. That's the first thing we have to do, because we have to set up the stock for this product or project to come out of. And we need to determine if the XYZ of the environment is going to match what we need for an XYZ on the machine that will make this. Sometimes they match right away. Sometimes things are pointing the wrong direction. So we're going to try to figure out how to get that changed and just follow along with the video. With the big thing, Z being an up and down direction. Okay, we need Z to go up and down. We're going to get X to go across the bottom, and we're going to get Y to go up along the stock material there. So I am going to change over on the left where it says model orientation. I'm going to select my Z and X. You could do Z and Y as well, but Z and X. And the computer's just asking, okay, Z's highlighted, like, tell us something that you think is Z in the workspace. So I'm going to go pick any vertical little edge. Click on that. There, Z moved. In fact, with that one selection, it also flipped X and Y the way I want it. Now this datum, or this little like ball joint there connecting the XYZ, it's not quite in the right spot yet, but at least it's pointing the right direction. And if yours isn't going the right direction, you may also have to click X, which I thought I would do, and I would have used like this edge to be X, which is not going to do anything, but you can also check these boxes to flip them if you're still not getting what you want. So it's a combination of picking edges, maybe flipping the axes to eventually get the XYZ in this orientation. And then what we can do is we want this to say stock box. We're going to click on the top surface, bottom left corner point. And that's where our 000 is going to be. This is how we get the computer to give out information that the machine can use. It has to understand where we think 000 is, and we're going to give it all these coordinates to move around and do the job it needs to. So with that, the next thing is to set up and make sure our stock is the right size. So click on this tab here, and we're going to change it from relative size to a fixed size, because I have a bunch of boards that are already pre-cut at 12 by 12 by 0.75. So if any of those numbers didn't match, you would just change them, 12, 12, 0.75. Now if you start changing those numbers and the board's kind of like going up and down through the middle of your part, you might not have your XYZ correct. So you'd maybe need to go back to the setup tab and make sure XYZ is all in the right direction. Like that. But if you come in here stock and you go 12, 12, 0.75, and everything, the yellow block is essentially matching the block that we brought into this environment, we're good to go, and click OK. So that first step is doing a setup that tells the machine how big our material is. And if I just click anywhere in the blank space of the browser, there we go. That was weird. Had to click on, click off, but that's just kind of a way to turn off the highlight that the setup was still doing. But click back on it. There it is. At any time, you can go back and check your XYZ, that it's the right direction, the right location. Click off to deselect. Now in here, in advanced classes, we get into a lot more about what 2D milling and 3D milling things do, but this is kind of an intro introduction to CAM and CNC. So we're just going to go with one operation, drilling. So click on the drill, and we're going to select our tool right away. And we'll get a pop-up window here. And if you minimize all these folders, what I'm going to have you do is see if you have CNC KHS tool library right here, a folder. And if you don't, we're going to pause. We're going to right click and add a folder. And then you would navigate to the group drive, teachers and students, Genota, and then CNC KHS tool library. Click on that and hit OK. And you may have to re-minimize these folders again. I think it expands them out for some reason. And then we're going to get inside the CNC KHS, and we're going to click once on CNC router. And there's the tool library that I'm slowly trying to build so that we have a lot of things pre-programmed for us to use. In this case, we want the 1/16 inch drill bit. So single click that and click select. And because we're using a library, the nice thing is I can pre-program what RPM and what kind of plunge rates you can be using with that. Now, it doesn't take care of all the setup. Still have to really carefully follow along and make sure you're doing some other things here. But it helps a little bit with RPMs and what we would call feed and speeds for this other area. Okay, we're going to move to the next tab, the geometry tab. And it says go ahead and select the hole. So I'm going to zoom in and pick any one of those hole surfaces. And if I go back to that browse area, it says, hey, you can select all the same diameters right now. So I'm going to check that box. And just like that, it auto-selects them, saves you a ton of time and a lot of clicking. Third tab is all about height. And we can run with the default numbers here. We're good. How far it retracts, where it thinks the stock top is, the feed heights, and so on and so on. And how far down all the work goes, in this case, the bottom of the hole. And then on the last tab, we are going to change the type of drilling we are doing. So a regular drill would be just down to the bottom hole, pull back out. Because it's a little deeper hole with a really small bit, we are going to do something called chip breaking with a partial retract. So chip breaking. And we're going to set that to a 0.1 pecking depth. And we're going to go 0.1 accumulated. We will go 0.5. And chip break distance is also 0.1. And I could explain all why we do that, but just make the numbers match right now, and we will be good. So what the drill bit does is it goes down 0.1 inch, retracts back up 0.1, goes back down does another 0.1 worth of drilling, goes back up 0.1, and eventually we're doing 3/8 of an inch, and then it pulls back out. But so this accumulated one is actually a little bit more than we needed, but we didn't need the drill bit to come all the way back out of the hole. Just doing that little bit of up and down motion while it's going down in helps save the tool life, keeps the tool a lot cooler, and it clears out the debris as it's doing the drilling work. So that's a good thing. So get those numbers to match. We click OK. And there's our first operation. You can single click on that and then simulate. And we don't need to see the big holder, so I'm going to uncheck that. I want to leave the tool in there though. I don't need to see the tool paths either. I'm just going to watch, and I am going to check the box for stock. And we can go ahead and click play. If you want to see that slow down a little bit, this is our speed indicator at how fast the simulation occurs. You can see there's that up and down motion. So it drills a little bit, lifts up, drills a little bit, lifts up, drills a little bit, lifts up, and then when it gets down to our total depth, it'll retract all the way out. Speed that back up a little bit. And what you're looking for in simulation is not only that it's kind of moving the way you think it should be, but this timeline should be green the whole way across. If you have any red, that's a really big deal. And we got some kind of mistake that we have to fix, okay? So if you have any red down there, go back and double check your numbers. If you can't figure it out, of course, let me know and I'll help you. And I let this go all the way through. All hopping around there. Looks awesome. And then I can close it. So simulation is good. Then what we would do is post-process this. So we need to create the code for our machine to run. Post-process. And you need to select right here, this drop box is our post-processor. Sorry, the post-processor. And you're looking for the Laguna CNC HHR. That's the post-processor we want. Post-processors are like a dialect of what we call G code. So all these machines run on something called G code. It's a machine language to move X, Y, Z, turn things on, turn things off. And these post-processors kind of put it in the dialect that their machines like to see it come through at. Then you can give this thing a name down here, and you can say, let's go SA for string art, and then your initials. And then if you had, I'm going to put number 1 for my first try. So string art, KJ, number 1. And you have to switch this to millimeters because that's what the Laguna router runs on. And then we can click post. And a little window is going to pop up, just asking where you want to save it, and you can navigate to your folder right away. You guys would be going to the group drive. I'm just putting some stuff on mine for testing here. There we go. And it should have your file name already. So you guys, again, group drive, teacher, students, Genoda, or just use your shortcuts. Click save. And if it all works out, you should get this pop up with all kinds of numbers on it. And sometimes it takes a little bit. There we go. So this is what the machine is going to see to do all of its work. And we get all kinds of Z numbers, X numbers, Y numbers. And that's all this is, just the machine constantly moving to these different coordinates, and of course then doing drilling at each one. So if everything looks good, you could also then now have a USB drive, jump drive in your computer, and you would do a save as, because it already saved your group drive. So if you just have a USB in here, which I don't have handy, I would just highlight it here on the left and then hit save, and that immediately transfers this to a USB drive, and you would be ready then to go into the router and do the work. Okay, and at that point, I'm sure I'll be showing people how to run the router and run the handheld controller, and we'll see some projects start to get made. All right, hopefully that helps. Of course, let me know if you have any questions that the video didn't help or cover, and we'll probably see you in one more video for making your document on this stuff.